Today, we shall be looking at variation. We will start by looking at the types of variation. Number one, direct variation, sometimes also referred to as direct proportionality. This is of the form y varies directly with s. This symbol is the symbol of variation or proportionality. In other words, y is equal to k times s. We have now introduced a quality sign and a constant in place of the variation symbol. K here is a constant. At this junction, we can now solve the problem, or this is the equation connecting y and s. The second type is inverse variation. This is of the form y varies inversely with s. In other words, you can also say that y varies directly with 1 over s. For this inverse case, it therefore means that y is equal to k all over s. If you cross and multiply, our sy will be equal to k. The third type is joint variation. A variation that involves more than one variable. You will see here that y varies directly with s and inversely with z. Y varies directly with s and inversely with z. Therefore, our y is equal to ks all over z. This becomes the relationship between y, s, and z. We have the fourth type, which is called the partial variation. Let's take, for example, the cost of an article, and the cost of the article is partly constant and partly varies. Maybe with the kind of design that you gave to your dress. For example, if you make a dress, you buy the material, the cost is constant. Maybe two people decide to buy the same material at the same cost. So the cost of the material is constant. But eventually, in sewing that material, one decides to have a design on his own, while the other decides not to have any design, plain. The cost of sewing will not be the same. So it varies depending on the design. In other words, the cost of the dress one is putting on is partly constant and partly varies. So in this case we have C partly constant plus partly varies with N. It is that variation with N that carries another constant, where A and B are constants. This is partial variation, not total variation. Basically, those four are the main types of variations we have. But there is an inclusion of the fifth one, which is like the fourth one, but this time around it is variation as the sum of two parts. In other words, C varies directly with S and varies directly with S cubed. Some cases you can even write C varies directly with S and varies inversely with the cube of S. Both are examples of variation as the sum of two parts. We shall now look at direct variation along with inverse variation in terms of problems. Let's take the first example. Most of our examples are adopted from past questions. The first question here is, if s varies directly as the square root of n, and s is equal to 9 when n is equal to 9, find s when n is equal to 1/7/9. Solution. You are told that s varies directly as n or with n. In other words, our s is equal to k root n, introducing the constant of variation. From the second statement, and s is equal to 9 when n is 9. So we have k times root 9. This is equal to 3k. Therefore, we can find our k, and that is 9 all over 3, and that is equal to 3. So we now write the equation connecting s and n, which now becomes 3 root n. So s is equal to 3 root n. This is the equation connecting s and n. Then the last statement, find s when n is equal to 1/7/9. So when n is equal to 1/7/9, we have 3 multiplying 1/7/9 means 16 all over 9. Changing it to improper fraction, and that will give you 3. Square root of 16 is 4, and the square root of 9 is 3. 3 will cancel 3, and the solution is equal to 4. So the final answer there, s is equal to 4, given the problem above. Question number 2. If w varies inversely as ub all over u plus b and is equal to 8 when u is equal to 2 and b equal to 6, find the relationship between u, b, and w. Our solution. W varies inversely as ub all over u plus b. In other words, our w will be equal to k times u plus b all over ub. The next statement says that when w is equal to 8, our u is 2, our b is 6, and then our ub is 2 times 6. And this means 8 multiplying 2 times 6, which is 12, by cross multiplication, and 2 plus 6 is 8, and then this is k. So at the final stage, we have that our k is equal to 12. The relationship, therefore, will be w equal to 12 into u plus v all over uv. You can now cross and multiply this to give you u/v/w will be equal to 12 into u plus v. And this is the solution to the problem. Example 3. The time taken to do a piece of work is inversely proportional to the number of men employed. If it takes 30 men to do a piece of work in 6 days, how many men are required to do the work in 4 days? Working at the same rate. Working at the same rate. In 4 days, working at the same rate. Okay. Now, our solution. Let T be equal to the time taken. And then let n be equal to the number of men. The number of men. This first sentence says the time taken T to do a piece of work is inversely proportional to the number of men, 1 over n. It therefore means that T is equal to K all over n. If it takes 30 men to do a piece of work in 6 days, so in 6 days, we have K all over 30. Therefore, the constant K is equal to 6 times 30, and that will be equal to 180. The relationship, therefore, between the time taken and the number of men is 180 all over n. Therefore, in 4 days' time, T is equal to 4, or in 4 days, T is equal to 4 will be equal to 180 all over n. If we cross multiply, we have 4n equal to 180. Therefore, our n is equal to 180 over 4. If we divide this, you have 90 over 2, and then eventually you have 45 men. 45 men will do that same piece of work in 4 days. Let's look at the exercise for the day. Number 1, given that y minus 4 varies directly at the square of s, and that y is equal to 7, when s is equal to 1, find the value of y when s is equal to 3. We have the options A, 31, B, 32, C, 43, D, 52. Number 2, the length a person can jump is inversely proportional to his height. If a 20-kilogram person can jump 1.5 meters, find the constant of proportionality. The options are A, 60, B, 30, C, 20, and D, 15. These are the answers to the exercise. Number 1, option A. Number 2, option B.